Okay, so let's do this this problem, this other buoyancy problem. And in this problem, we are going to take a slightly different approach. We're going to actually measure the fluid in which some object is immersed. And what we're told is we have a chunk of iron symbol Fe on the periodic table. And that piece of iron has a mass of 390 grams. And when weighed in this unknown fluid, it has an apparent mass of 350.5 grams. Okay? So using that information, we can calculate the density of the fluid in which it's immersed in. And so the trick here is to note that the density of our fluid that we're interested in, okay? And what we're going to do, we're going to calculate the density of the fluid that this mass displaces. So we're going to calculate the density of a chunk of this fluid that has the exact same volume as our chunk of iron that's immersed in the fluid. So therefore, it's equal to the mass of the fluid displaced by this chunk of iron divided by the volume of fluid displaced. Okay, so that's the approach we're going to take here. And remember, the volume of fluid displaced is equal to the volume of the object. So this is therefore equal to the mass of fluid displaced divided by the volume of the object. So we have two steps here. We need to figure out the mass of the fluid displaced, and we need to figure the volume of the object out. Now, the volume of the object can be found by its mass and density of iron. Because remember, the volume of an object is related to density and mass by this. It's the mass divided by the density. Okay? Because density is mass divided by volume. The volume is then mass divided by density. And the mass of our object is 0.390 kilograms. It's 390 grams. So 0.390 kilograms. The density of iron, you have to look this up somewhere, the density of iron is 7,800 kilograms per cubic meter. Okay, so the volume then, the number you get, it's 5 times 10 to the minus 5 cubic meters. Okay, so that's going to go in to here in a little bit. So that's step one of our problem. Step two, we need to figure out the mass of fluid displaced. And that's where Archimedes' principle comes in. So remember, we can calculate the buoyant force in two different ways. The first is by considering the dynamics of the situation. So we have some weight of our object, a force pulling down, that's equal to its mass times the acceleration due to gravity. So its mass is 0.39 kilograms, and multiply it by g, and that's our downward force. Now, presumably this iron chunk is suspended in the fluid by whatever scale we're using to measure it. So therefore, there's an upward force from the scale that is equal to the apparent mass times gravity. So it's having to pull upward with a force of 0.3505 kilograms. Remember, that's its apparent weight in the fluid, times g. Okay? So kind of hard to see up there, but there's 0.3505 times g. That's the downward force on the scale. Therefore, there's an upward force on the object equal and opposite. Okay? And then there's a buoyant force from the fluid. So therefore, the buoyant force, for this iron chunk to be suspended in the fluid, that buoyant force has to be the difference between the downward force and the upward force. So the buoyant force then is the difference between these two things, which is 0.39 kilograms minus 0.3505 times g. Okay? So that's the buoyant force calculated by considering the dynamics. Now we can use Archimedes' principle to calculate the buoyant force. And the buoyant force is equal to the weight of fluid displaced. And the weight of fluid displaced is the mass of the fluid times g. The mass of displaced fluid times g. Okay, and remember, this is what we want to find to calculate the density up here. So therefore, these two things here, this and this, are equal to one another. Okay? So therefore, that minus that gives you the number 0.0395. So that's that minus that, 0.0395 times g. Okay? And I'm going to erase some of this stuff over here. Okay? The g's cancel. And therefore, there is our mass of fluid displaced, this number right here, 0.0395 kilograms. Okay? So now we have all the things we need to calculate the density. And to do that, I'm going to erase this stuff over here. So the density then is equal to the mass of the fluid displaced, which is 0.0395 kilograms, divided by the object volume, which is 5 times 10 to the minus 5 cubic meters. Okay, so you do that calculation, the number you get here is 790 kilograms per cubic meter. So it's not water. Water has a density of 1,000. So you can look this up in a table. I believe the textbook even has this value in its table. That's ethyl alcohol. It's basically drinking alcohol then. And so this is a good example of how to identify the fluid, identify a fluid by utilizing Archimedes' principle.